I'm Reverend Chad Cooper. I am the Executive Director of Sustainable Sanctuary Coalition. We're an interfaith environmental organization, and we're a co-sponsor here. We're really excited to have Dr. King back with us. I'm sure Dr. King can share more about himself, but he is a retired Brigadier General from the Army. He received his PhD in environmental engineering in 1988. He has been the Chief Academic Officer at the United States Army Command and General Staff College. Been deployed numerous times, just knowledge beyond compare, and we're so excited to have you, Chris, with us. And so without further ado, I'll turn it over to you so you can have as much time as possible to share all your wisdom with us. Thanks for being here, Chris.
You're all very welcome, and you're all too kind. It's always a pleasure to get to talk to this group. It's a good time to talk because of, as you see in the title here, the IPCC 6th Assessment Report on Climate Change just came out, just a science report. And I'm going to give more details about the IPCC. If you don't know what it is, we'll get all of that caught up for folks that I haven't had the pleasure to visit with before. But my summary of what they said is we're at the code red point in the time that we have available left to deal with this problem. We're still with some significant pain and agony from the consequences of what we have already done to impose climate change on us, but to avoid catastrophic, maybe world-ending kinds of consequences on paths that are ours to choose is where we are with this. Code Red also describes what you see in front of you as the visual that I put on the front slide, which shows the temperature ranges between making good decisions and making bad decisions about how we go forth with climate change. And what you see on the right is the possibility of the temperature domains up to 11 degrees centigrade, higher than they are normally in the United States over the next 75 years if we don't make the right decisions and start responding aggressively.
I can't see slides. I hate to interrupt, but I can't see the slides.
Are the slides up for others?
Yeah, I can see them, Chris.
I've got them, Chris.
I don't know what I can do to fix that one. I'm sorry. I'm not that great at this. Jerry?
If you go up to the top of your screen, you'll see viewing options, and you can click different modes, side-by-side mode, and then up in the top right corner, you can see view. You can pick standard, side-by-side gallery. That should help bring up the slides for you.
You're on. She was on mute.
I'm on my iPhone, so I actually don't have that.
Oh, on an iPhone, you may have trouble with that because the formatting between a computer and an iPhone is different. I've seen that problem come up before.
Okay.
I will try to be descriptive when I talk about my slides. And what I have up now is a map of the United States showing two of the future possibilities for the temperature domains across the country. And the worst case is continuing to discharge at the rates we're discharging now. And by 2100, that could produce from 4 to 11 degrees centigrade temperature rise in the United States. All right. Wait a minute. Now my slides seem to have locked up. Okay, I got it there. All right. And I always slow that you all have seen me before, have seen this before. This came out in actually the Kansas City Star back in 2015, just before one of my presentations. The slide says, okay, so what's the left-wing bleeding heart liberal group that's talking about climate change now? And it's got a picture of me standing behind two folks in front. The picture of me is in a military uniform. because the United States military had just issued its assessment of climate change and its security implications. That was back in 2015. It's not just a liberal, tree-hugging, environmentalist kind of concern, and it hasn't been for a long time, actually. I do this because I am firmly in the belief that climate change is the major existential threat to security for our nation and for the world. This falls into the academic domain of something that I started working on a long time. I started working on this in 1991 when I became a faculty member on the environmental engineering faculty at the United States Military Academy, teaching at West Point, teaching environmental engineering because we had decided to start an environmental engineering program as part of the curriculum at West Point. When Rick was there, they didn't have stuff like that. Their only choices were what kind of ring they were going to get. They didn't do much about majors and stuff like that. But the Army decided that having environmental engineering at West Point would be better for the Army and better for actually attracting cadets, top quality people to come to West Point, because it was something young people were interested in. I studied this under the domain of what's called environmental security. And this, after years and years of research, is what I finally defined as a definition for environmental security. And I highlight the part that it's any change in the environment that denies people their basic human needs. If people, where they're living, cannot provide clean water, human health, the food that they need, some other basic human needs, then it becomes an insecurity and instability problem for those people. And if it's large enough, it becomes a security problem for the region or the nation or many nations. Climate change is one of those, not the only one of the environmental security issues. When I started in 1991, I was sure from looking at the data that the biggest environmental security problem at that time was water scarcity. Millions of people were dying at that time from dirty water because they didn't have clean water. And even more people were being threatened by not enough food, water to grow their own food. Another environmental security is deforestation. Another one is desertification, the loss of the ability to grow food because of desertification in many parts of the world. Those are the domains of environmental security. Climate change has become the 800-pound gorilla to describe it in that context, though. And so I started in 1991 and very quickly found out I wasn't inventing anything at all. Academics at places like Oxford and Cambridge and Harvard had been studying this for quite a while. And this definition is the best I have found still that talks about it, both showing the breadth of the problem, but also demonstrating that this made a lot of sense a long time ago. So for those folks that maybe cannot get the screenshot, I'm quoting Norman Myers from Oxford University in 1986. National security is not just about fighting forces and weaponry. It relates to watersheds, croplands, forests, genetic resources, climate, and other factors that rarely figure in the minds of military experts and political leaders.
I am able to get your screens right now.
You are?
Yep, figured it out.
Okay.
We're good. Thanks.
All right.
Okay.
I like to supplement Norman Myers' idea about things with something from a strategic historian from back in the World War I era, which is a guy named H.D. Liddell Hart. And what he said was, that relates to my work, was the only thing harder than getting a new idea into the military mind is getting an old one out. So it has been a struggle to get military to recognize environmental security and climate change as something that they ought to be thinking about in a strategic sense. But I am pleased to say that we're getting past that point. Everything that we do in the military has to be described or consolidated into what we call our national security strategy. Every president is responsible for producing their version of the national security strategy. It obviously then changes from one administration to the next, and it has certainly changed over the last 20 years. What I'm showing you here, and I'm not going to read this one, is the interim national security strategic guidance that was issued by President Biden. And it recognizes that climate change indeed has a place in the thoughts of our national security strategy. It is a threat and a threat multiplier for national security, strategic national security, in the context of the global climate change agenda, SEC. So from this, we will get a national security strategy, and I'm very hopeful that it is very strong on what we have to do as a nation, recognizing this national security strategy is not a military document. It's from the President of the United States, and it describes to everybody in the executive branches of government what they should be doing to maintain our national security. So it's a whole of government document. In the case of climate change, we'll see that climate change has a strategic military implication to it, but the military is not the lead in the process here. Other parts of the government have to be in charge of that. About 5 years ago, I wrote an article and published it that said we were in a bad organizational structure to try to deal with climate change. We were trying to deal with climate change by each of the departments in the executive branch taking a little piece of it. The Department of Homeland Security, Department of Defense, the Department of Energy, all of those had a little piece in the pie, and they recognized it, but their response were inside the stovepipes without any integration or any grand plan to deal with that. I'm hopeful that the appointment of John Kerry can kind of break some of those stovepipes down, and we have one guy in charge now that can then deal with an integrated answer to this. It's certainly better than we've had before. So I'm dealing with that as a very positive change. At least he was at COP26 and representing and speaking for our nation, which we had not been doing before. So what are we going to have to learn from the science? I'm going to spend most of the rest of the time talking about the science that's in the new report that just came out. And what we're going to have to learn is what and why. What is changing and why is it changing? Those are the big questions. Climate change, it's occurring very rapidly. Increase in land surface temperatures, increase in ocean water temperatures, decrease in Arctic sea ice, land snow cover, and glaciers that are retreating at rates we've not seen for thousands and thousands of years. Sea levels rise, and I'm going to give you, that's one of the things we hadn't perfectly defined in previous work. They're rising at accelerated rates from what we saw before. Land biospheres are moving, and that will be a subject we're going to talk about. And as we were talking about in the preliminary work, Jerry, extreme weather events are going to be more common and more intense. All of these things have been very, very well documented and very, very well researched in this report that we're looking at. The question about how much of the climate change is driven by human activity has been resolved. What we are seeing right now is 90% plus driven by human activity. And then we're going to close with talking about the 5 scenarios. What are the futures that are in front of us, and what do they then yield as a climate change response? So that's what we're going to try to go over in the next 45 minutes or so. Any questions from anybody? Any comments? I'll break every once in a while so we can have that period. If you do, speak up. Okay. This is an important thing to look at and understand, because this really also tells the story of how environmental security works. This is somewhere in your education between your 5th grade and your 7th grade courses that you had, what you would see in a physical geography discussion that you might have had, you should have had, to describe what the world looks like and why it looks that way. And this is a picture of the climactic regions. What a climactic region is an ecosystem that has a common set of values so that they look alike. We use this in the Army a lot so that I can look at the little desert part that's in the Southwest United States, and I can look in that and I can tell the troops that that looks somewhat similar to some of the deserts you would see in Saudi Arabia and Kuwait, Iraq. The dark green, I worked and studied tropics for the Army. The dark green rainforest that you see in Brazil and through the central part of South America, through the central part of Africa, and into the island nations, those are defined as rainforests. Well, what defines those regions? It is defined by the rainfall and the temperature, and how that changes over an annual cycle. So does it rain constantly and does it rain heavily? A rainforest is defined by constant hot, constant wet, at least 80 inches of rain a year, up to 120 inches a year. It's warm all year round because that's where the equator goes through. And so you would see those are common grounds there. The deserts are defined by drier than 10 inches of rain a year total and extreme heat. But there's also cool, dry deserts too, such as you would see in Mongolia. So that's what climactic regions are about around the world. The previous slide, we said climactic regions are moving north. And what that means is as it gets warmer, the cold regions, which are on the north or the upper part of the map, those regions are moving north. It is getting warmer and wetter in those regions because of climate change. There's winners and losers in that. Obviously, the big losers is in the Arctic, as the ice melts and that whole Arctic domain gets transformed. From a security standpoint, we worry about that because now we have a totally unguarded border that we've never had before. We've always depended on the ice in the Arctic to be a buffer from any sort of military incursions or aggressions from that side. You can't do that anymore because during the summer months, that is now navigable. That's never been an issue for us before in the United States. It also opens up opportunities for development. But the real point is, as these regions that you look at move, and particularly those regions where humans live, that changes the conditions for that life. If they have less water than they had before, that becomes a threat to growing the food they need, having potable water to sustain themselves. If we have more floods, that is a problem. If we have sea level rise where those lands become inundated and they will no longer support population growth, that creates a problem. So what we're saying is climate change is redrawing this map that we've had for hundreds and hundreds of years and have existed for thousands of years into a different set of circumstances, where these regions of the world that support us at human activity and support all natural life forms are transforming, sometimes not for the good, particularly for the human security domain. That's why climate change is much more than just warming, and we have to recognize it as much more than that. And that's how it becomes a security threat, because many people around the globe, the 7.5 billion people there, now live in places where climate change is making it less and less habitable. And that's my definition of environmental security. And that's why it's a security threat, and we'll talk about those threats as we go on. Any discussion on that one? I mean, that's... So we got to that. So what is this, just as a refresher for many, what is this Intergovernmental Panel on Climate Change? It's a UN established program established in the mid-1980s. People looked at the work that was being done in academia, at the work of Norman, how about getting that? Norman Myers, a guy named Levy, a group of about 15 or 20 eminent scientists that started telling people, we are doing things to the environment that are changing the way we can live and exist on the earth. And so the UN started looking at climate change as one of those significant environmental changes. The data was starting to show the warming. 1990, they published their first report. That was called the AR1 report, assessment report. To date, all 195 members of the UN have participated in it. They have provided scientists to the process. The scientists don't, most of them do their own individual research, but as part of the IPCC, they don't do research. They collect their research and they evaluate research, and they try to peer review that data to see what is the best science about how the climate's changing, what are the causes of that, and understanding the many complex biological and chemical systems that are controlling how our climate acts. The simplest ones are the ones that are meteorological. How much sun's energy is coming in, how does that react with the environment? But there are very complex chemical and biological systems, such as how biological systems are able to sequester carbon dioxide. What is the chemical reactions that are going on in the ocean? All of those kinds of things have been collected and analyzed, and new research has been put together to try to support understanding these systems better. The sixth report that's out now is the physical science report. You see in the slide, the assessment reports are usually in three parts. The first thing they do is they gather the science and they publish what can we say about the science with strong sense or strong understanding of how accurate that science is. Sometimes they look at things and say, we believe this to be true, but there's a certain error bounds around trying to say something specifically about that science. After the science is done, then they take those results and say, what are the impacts? How do we adapt? And what are the vulnerabilities they call? And that's in the second report. And a third report will be issued lastly is mitigation. How are we going to reduce the impacts, the adverse impacts that we see from the science and the vulnerabilities that climate change is producing? So each cycle of assessment reports goes into three parts. So in probably within a year or two, the AR6 impacts and adaptations and mitigations reports will be published, but they're not out yet. So all I'm dealing with is the science report right now. It's a nice, neat, quiet 3,949 pages to get through. Thank goodness. Go ahead, please.
Question.
Yeah.
Okay, so all of the scientists from the different countries that work on this report, do they just do it for their own country? Do they divide differently, like into categories? And do they do a peer review? You said they try to do a peer review, or
they
not?
They absolutely do peer reviews. What they do is the scientists, they don't look at their country at all. They look at their, if they're a climatologist, they look at that. If they're a bioscientist, they look at the, they are put together in the scientific domains that they work in. So you'll have, I've worked on these things and I work with an Iranian scientist. It doesn't matter there. In fact, to me, it's one of the best things the UN has been able to do to get the countries to work together on a common problem. It's probably the most successful thing they've had. Very seldom does the UN get much agreement or get it out of the political domain. This has been able to avoid the political domain. The thing it deals with now is the scientific ego. I've done my work and I want to prove it to be good, and I want to maybe prove that somebody that got a different idea maybe. So when the scientists are willing to sign off on this report, and this report will have 200 principal authors, that science has been tremendously well vetted. So there is always an executive summary. The executive summary for the science is just 41 pages. And you can go to the UN's IPCC site and you can get it and you can read through it, and you can get most of the figures that you'll see that are forthcoming in this discussion. And it's a little scientific mumbo jumbo. I think most people can get the big picture of what's said. Now, when they go to the other two reports, they will write those much more in lay terms. They'll be trying to talk to the general public, but the science one sticks to being focused on primarily the scientific community. Good question. Anybody else?
Yes, Dr. King, this is Al Frisbee. I think this is the fourth time I've heard you speak. You do a wonderful job. Question is, what's your personal opinion about using carbon pricing across the border as a mitigation effort?
I think Al, you've heard me say this before. My solution is always going to be all of the above. That is part of all of the above, in my view. I think it's particularly useful right now to get this thing started. We've got a lot to do, but there's more and more consensus that that's accepted. And I think the new US policy is that part of the solution has to include that.
Good, thank you.
Okay, good question. They're all good questions. All right, so I'm going to generalize and then we're going to deal down into it. Human influence has warmed the climate at a rate unprecedented in 2,000 years. That's right. We're quoting right out of the report. Greenhouse concentrations, well, as you're going to see, greenhouse gas concentrations, particularly CO2, are at 2 million year historical levels. It's been 2 million years since we've seen that high. Every ton of carbon dioxide adds in a linear fashion to global warming. They've never been able to prove that before, but the data is now irreconcilable to counter arguments. Projected changes in extremes, hot, extreme precipitation, droughts, tornadoes, hurricanes are going to be larger in both frequency and intensity. And that's just pretty much obvious. It's a basic law of thermodynamics. When you put more energy in the system is going to try to drive it to equilibrium. That's what climate does. It tries to go from higher levels to lower levels so that we establish equilibrium. If there's more energy to be discharged, it will be done in the basis of higher climactic weather events. There's no other way for the system to try to maintain its equilibrium. And then the red line, our efforts in reducing human drivers to climate change have failed to even slow it down because our efforts have been ineffective. Okay.
Chris, I have a question. Jerry Reese.
Yeah, Jerry.
What is the lag time if we were to suddenly stop all excess greenhouse gas emissions? We've got some built-in momentum here. What's the lag time before anything could even begin to improve?
Well, first of all, trying to base something on the hypothesis that we quit dumping all the carbon dioxide is irrelevant, because that's not going to happen for the next 20 years. We're going to hopefully, as rapidly as we can, wean ourselves off of that. The lag time for carbon dioxide in the atmosphere is 100 years. It's got a residence time of that. Methane, over 25 years, it goes from being quite virulent to about the same impact as carbon dioxide. So its impact dies off fairly quickly. Nitrous oxide is more reactive. Ozone is very, very rapid. So we don't spend a lot of time worrying about ozone. Even though it is a greenhouse gas, it is an unstable chemical compound in the atmosphere, but we generate a lot of it locally. So the answer to that, let's go back and look at the AR5 report. It was based in 2015 to 2050. If we could get control over that 35 years by greatly reducing the amount we were putting in every year, we could level off at 2 degrees centigrade. We're not going to make that. We're going to go over that now. So what we're looking at now is something greater than that. And the rest of the answer will come when we look at the scenarios that they're proposing as to how quickly we're able to reduce the amount of carbon dioxide we're putting in the atmosphere. But by 2050, we are still going to be growing the temperature, Jerry, is the answer, even with aggressive reductions in carbon dioxide. So water vapor, we don't worry about. Water vapor is natural. We don't add significantly to that. It changes over time. But on the average, it's not a producer of the global warming we're seeing. Carbon dioxide is the primary culprit, the product of burning coal, natural gas, any energy source to collect that energy and use it for human uses. We are producing right now at growing rates, and we're going to look at that. But we've never had carbon dioxide at the levels they are now for the last 2 million years. Methane has grown significantly, but the number and the history of methane is not as good, because our methods to look back in time are not good, because methane decays over time. Nitrous oxide is another production by industrial cars sources. The reason it's listed is because it's very, very, very strong. Nitrous oxide is 265 times more effective as a greenhouse gas than carbon dioxide. That's why even 300 parts per billion is significant when we try to total up the total impact of greenhouse gases on an annual basis. And what we do to get the magic number that we're going to look at over the next couple of slides is we do everything on the basis of carbon dioxide, but we turn methane, nitrous oxide, and ozone into carbon dioxide equivalents by multiplying the number of pounds of those times their greenhouse gas effectiveness. For example, for methane, you multiply it by 35 to get its equivalence to carbon dioxide. And there's one other thing about that. Each one of these chemicals has a different residence time. I already pointed that out. For carbon dioxide, it's 100 years. For methane, it's 25 years. So over time, that also determines the total greenhouse gases. And sometimes what we do is we use the carbon dioxide equivalents for 25 years as a way to get to a single number to look at what we've done to the environment on an annual basis. So here are the numbers as they are reported in the AR6 report. The average temperature over land from 2011 to 2020 is 1.59 degrees over the 1880 to 1950 database. The human cause component of that is about 1.1 degree. The ocean has increased 0.88 degrees centigrade, because 90% of the excess heat produced by climate change goes into the ocean. It's not in the atmosphere. And the ocean warms much, much slower. That's the pH is dropping in the ocean and oxygen levels are decreasing. And those are very significant factors for all activity in the ocean, mostly food chain kinds of issues for we as humans. Oxygen levels decrease the productivity. The pH does damage to the smaller organisms, so the whole food chain is disturbed by pH and oxygen levels decreasing and the temperatures warming. The cryosphere is one that's a very significant issue, and I always use the Tibetan Plateau when I discuss this to folks. I'm not going to do that today, but the loss of snow and ice cover changes the whole hydrologic cycle in many places very significantly. Certainly in the western United States, in the mountains that depend on snow melt and snow accumulation. The same thing in the Tibetan Plateau. The seven major rivers of the world that come out of the Tibetan Plateau depend on ice and snow cover, and that's decreasing very, very rapidly. It's one that's discussed often, but we don't have the absolute understanding of in the cryosphere is the loss of permafrost. You understand that's a problem because if you're living and building and trying to exist in the northern climates, the permafrost is something that was depended on when structural design was put in there, and without the permafrost, that gets to be an issue. The big scary part of that is if we were to lose the permafrost and it were to release the massive amounts of methane that are trapped in the permafrost, because most of the permafrost is an anaerobic environment, which means that it's not oxygen and CO2 down there. It has trapped a massive amount of methane that's produced in the anaerobic decomposition process. And then extreme weather, droughts, hurricanes, floods. Jerry Reese just sent me an article that talked about the cost of the extreme environments, damage from hurricanes and floods and droughts, moving into the trillions. I had a researcher, a young major that worked with me at the Command and General Staff College, and he looked at just hurricanes in the Gulf Coast area of the United States, using what we had seen over the past 10 years, the military response to those, and what was anticipated in the next 25 years. And his numbers confirmed that was the damage just in that part of the world would be in the trillions, and a significant amount of land loss that would not be recoverable. This is out of the AR6 report. This shows, as you go across, 5 different maps, and those are the 5 different maps of the different levels of warming that we would see from 1, 1.5, 2, and 4 degrees. And you see, if we drive to 4 degrees, we're looking at many places in the northern hemisphere warming up to 7 degrees, and just about all of the inhabited lands warming from 4.5 to 5 degrees centigrade.
Chris, Jim Turner has a question for you.
Please. Where are you?
Hello, Dr. King.
Hey, good to see you, Jim.
Yeah, good to see you. Well, I put my question in the chat. I'll read it.
Please.
The hydrologic cycle can transfer heat from soil by transpiration. Formation of clouds and rainfall then release that heat in the upper atmosphere, where it can radiate into space. Granted, modeling of the atmosphere is complex. Soil enrichment can make soil able to hold more water so that it's available for more stable transpiration. Is this something that the IPCC science report discussed? And further,
I just flipped to one of the last slides, and there you'll see the amount of soil column moisture change based on the different scenarios that they're running as their futuristic set. So, Jim, the answer is yes. They both try to model what that soil moisture loss is going to be, and they add it into the overall impact on the warming of the land. And of course, the reason we do this is also because that has a massive effect on the amount of food that you can grow in those different regions. So yes, it is absolutely one of the significant considerations that they go through when they do their full analysis.
thank you.
Oh, sure, glad to. We'll go back where we were, but it's good to see that I found something that was useful to somebody. All right. So what we're doing then, if we look at these temperatures are rising, incremental warming maps, we're looking at what choices are we going to make. We're already stuck with 1.5 degrees. That's what we've already seen over the land. That's why that map B looks like it does. Are we going to make choices that we can live with the 2 degrees centigrade warming? Or are we going to make choices that see us at the 4 degree warming and all the associated impacts that does have? And we're going to talk about those as we go forward. Now, I'm sorry, I have lost my camera, but you all know what I look like now, so we don't need. So I told you earlier, the debate about whether this is human induced or whether this is natural systems is over. There is no science anywhere that supports that this is a naturally occurring event or is equally divided between natural and man-made systems. The figure on the left shows the warming that we've already seen and shows how anomalous it is from the past 2,000 years of history. The figure on the right shows, Jim, you just talked about the complex modeling that was being done. The modeling has gotten better and better and better. And what this shows is for all the models that we have and all the data we have back to 1850, which is, the period of time that we have significant data, you see from about 1980 on, the actual temperatures and the model temperatures, which are shown in the brown area and the black and the brown lines, hard lines, shows that the models accurately predict what we actually saw when we take human and natural and put them together. They also shows that the line in blue is what we would have seen if there was only naturally occurring climate change. When those two curves separated, the white space in between says that there are no natural systems that would produce the results that we have today, the actual data, the actual facts of temperature that we have today, just based on the natural system. Human-induced climate change is the primary driver in separating those two curves. If we had natural systems, we would be at the same temperatures we were in 1850. Is another way of looking at that one. And the error bounds on the models have gotten smaller and smaller. They much more accurately depict the actual data that we've been able to measure. And they have much more detail, like Jim just talked about. Is that soil moisture accounted for and its impact? Is the radiative effects of having particulates in the air that reflect energy and act to lower the temperature, are those accounted for? And the answer is yes, 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 and yes. We have accounted for everything we know, and we have a better picture of how our climate works than we ever have, ever. And it's all been because of the climate change research that's gone on, driven somewhat by IPCC, but driven by the natural curiosity and the recognition of a significant problem that needs a scientific answer that has occurred over the last 25 years. Every ton of CO2 adds to global warming. On the x-axis, we have total tons of CO2 that have been dumped in the atmosphere. And on the y-axis, we see the temperature rise. In black, what we see is the actual system, what's happened and what's been measured as we've added CO2 since 1850. And what you see in the colors and what we're getting ready to talk about are what's going to happen in the future. What happens if we keep dumping these amounts of carbon dioxide into the atmosphere over the next 50 years? Oh, it goes to out to 2050. And I'm going to explain more about those numbers as we go along. But it's basically a 1-for-1. As we add massive amounts of carbon dioxide to the atmosphere and it stays there for 100 years, the temperature's rising linearly. That's a straight line. That is not a mathematical plane with numbers, but a straight line linear progression based on the tons of gigatons of carbon dioxide that have been done. A gigaton is 10 to the 12th tons. That's a lot. I don't want to short sheet this as this is a problem that's easy to fix. I just like this slide, by the way. That shows fuel efficiency, and it shows what the world may look like sometime soon too. I'm going to just use U.S. energy consumption as an example. The world is quite a bit different than that, but I love this chart because it really gives us a lot to work with, and we're going to spend some time here. I hope you guys, Jerry, can you read some of the numbers and stuff on that? All right, Jerry, you're muted. Anybody, can you all read that?
Yes, I can see the numbers.
Okay.
I see the numbers also.
Okay. So on the left-hand side, we have where we get our energy from in the United States. On the right-hand side, we show how that energy is used. And what has been added here that I love is in the middle, it shows the process that we have to go through to get that energy from its source through the system that we have into the user. And I'm going to use coal as an example because everybody that's heard me before knows I hate coal. I hate coal for many reasons. One is, if you look at coal, it shows that 9.2 quadrillion BTUs of energy was in the coal that we burn. 90% of it, look very carefully, the little blue line, 90% of it is lost through the production and in the transmission of that energy to its user source. 10% of it is going to go to commercial and residential uses. That's one of the reasons I don't like coal. It's so dadgum inefficient, it's awful. The second reason I don't like coal is 90% of that is burned and produces energy. It goes up as CO2 and particulates and stuff, but about 10% of it's left as coal ash, we call it. And the coal ash has to be stored, managed, and disposed of. Well, what's going on in the US energy system right now, and for the last 50 years, is that has been stored, but it has not been disposed of and it's not cleaned up. So every place you find a coal plant, you'll usually find a coal ash pile or a coal ash pond, which is a massive waste pile that contains uranium, beryllium, cadmium, molybdenum. Every toxic metal that's known to man is in those coal piles. And they're not being cleaned up. They're just being left there. So as we abandon coal mines, and coal mines produce waste too. I won't even talk about that. But at the plant level, we'll find that these coal ash piles are laying around. We had one break in Tennessee. They had to clean it up. It destroyed a river for a very long time. And in the cleanup process, dozens and dozens of people were killed from cancer that they contrived because they weren't given the proper protective equipment to do the cleanup process. And now there's a huge lawsuit to try to recover, but you can't get those dozens and dozens of people's lives back. And that's just a ticking time bomb that's everywhere. So I'll get off my diatribe about coal. The good news is coal now 9.2 quadrillion BTUs. In 2008, that number was 29.5. So we have reduced coal by a third since 2008. The use of coal has been reduced by 2/3. Reduced by 2/3. We're only burning 1/3 of the amount of coal we were in 2008. That is some good news. Renewable energies is now listed as 11.6 quadrillion BTUs, or about 12% of the total energy. That's up from 7 in 2008. Not near as much growth as we would like to have. Natural gas is about the same, and we're burning more petroleum than we were we're burning less petroleum than we were in 2008. Now I'll make one caveat about this. This is the number, these are the numbers that I derived from 2020. Why is that significant? That was our COVID year.
Yeah, before the pandemic.
It was during the pandemic.
Oh.
2020. People drove less, people did a lot of things less, and there was a natural drop of about 7%. The best year we've had for energy reduction was the COVID year. So I want to make a couple of comments about this and then have a little discussion here. The little gray and black box down here that represents the energy losses in quadrillion BTUs through electrical system losses and the retail sales component losses. The thing I would say about that is, if you look at what we've talked about in this Build It Back Better America project, a lot of that's about infrastructure rebuilding. And a significant part of that infrastructure, not a significant, but a portion of that energy structure, that Build It Back Better infrastructure addresses the electrical grids, which are old and dilapidated, or worse, depending on how you look at it. So we may have an opportunity, if we do some of that work, to make a significant reduction in the total amount of energy that we're using by not wasting as much of it on the transmission and the old power systems that we have in place now. So for me, this slide shows some opportunities that are available to us to recognize how we can get some quick wins on mitigation of the climate change gases. Certainly continuing to reduce coal and raising the amount that's renewable energy are two things that we see from this drawing. And quite honestly, a lot of the technologies we'd be using are already available. It's just getting the will to implement those kind of changes. If we put the same kind of money that we put into coal and oil and natural gas development subsidies into renewable energy subsidies, we could transform renewable energy into 30% of our source very quickly. So the other side of it is, how do we reduce the end use sector? How do we reduce those that are transportation, residential, and industrial uses? And there are lots of opportunities there too. To me, go ahead, please.
Oh, I have a question. Yes. Where does your agricultural use, end use, fit into the right-hand side for agricultural production?
The problem is it'll be a couple of places. A lot of it will be in the transportation. So if they're transporting wheat from the field to the processing plants to the manufacturing plants, that would be in transportation. If you're just talking about pure agricultural use, it's in the industrial. If you look at the amount of gas that's in the tractor to plow the fields and do that kind of thing. So it's kind of scattered about.
Okay.
Dr. King, question. Where's the hydroelectric on your left-hand side?
It's in the renewables.
In renewables? Okay.
Yeah.
And I noticed that nuclear is 8.2. What's your opinion on increasing nuclear power plants? Until we get the technology breakthrough, which I think will happen so that we can go to small scale plants, the nuclear is exactly the number of quadrillion BTUs it was in 2008. And that will not increase until we go to a new technology, I don't think, Al. I think trying to put a conventional reactor in place will never happen. We have in the TVA system down where I live in Tennessee, there are 2 or 3 abandoned plants that are already stood up that were never operated because of the environmental concerns and the risk analysis for those plants. So that's my personal opinion. I don't see it until we get new technology, but I think they're getting pretty close to new small scale, lower energy levels. I'm an optimist about that. I think in 100 years, they'll be digging up all the stuff we buried as high level waste, and that will become nuclear energy for the next generation of small nuclear power plants. Fusion or fission?
I don't know which will be. We think it's fusion, but it may be something we don't know about yet. The impetus to work on that is also coming out of the needs for other sources of energy. So the national labs are working really, really strongly on that. But I don't know about you all. We can have a little discussion here. I'm optimistic about what the public sector is doing to pick up on what we need to do and move towards more renewable energy, less waste, less carbon-based fuels. It's not going as fast as we'd like, but I think they're working at it. I see more and more evidence of that. When we see Ford's making trucks that are going to be plug-ins, that we're going to, and hybrids, and we're just seeing more and more of that. If the government would get out of the way, maybe we'd get some more progress on that. I think the government's been pretty much obstructionist on some of the things we might see protecting has-been energy systems. Okay, then there's one other I will throw in here as just as a personal thing, but I know we've had this discussion in our meetings before, Jerry. How much of this is because these two curves look so much alike? World population growth and carbon dioxide emissions in total gigatons. I know in the United States, the energy use per capita, we have been able to control and actually reduce it a little. But if we look, we're actually producing more than we were 20 years ago. And it's because of growth, population growth. But then if you look at a place like India, where the population growth is so dynamic, and you'll see their growth curve in a slide or two. There's no question that this is a significant contributor to the world scale problem of climate change, because each person has a carbon footprint. Whether it's little or big, depending on where you live, it is a significant issue. Speaking of the footprints, so what we see in gold is the footprint of China. We see the US. We see Europe, which is in blue. And then we see India, which was climbing and passing Europe, and quite honestly, I think has now passed us in the United States as far as the CO2 emissions in gigatons per year. How do we control this major piece? This represents in total a significant amount of the total carbon dioxide that's added to the atmosphere on an annual basis. Just these four groups. All right. So we don't know the answer to that question I just asked. We don't know how we're going to get there, but what we can do is use a futuristic approach to say, what do we need to do? First, you got to figure out what it is that you've got to achieve as far as reductions, and then you start fighting over how you get to that. So what I put on the left is the best I could to decode the AR6 report on the futures. They will define a future as the SSP, which is the shared social economic pathway. And if you ask me to explain that, I'm going to take the Fifth Amendment. I plead ignorance on that one. But what I do know is that what it does is it has defined 5 different pathways. We had 4 before. In this report, they've gone to 5 different pathways. And what it does, it based the 5 pathways on the radiative forcing function. How much stuff have we added to the environment that causes the heat energy to be absorbed in the atmosphere and cause climate change? So a smaller number is better. The smallest SSP they use is 1.9 watts per meter square as the forcing function. The largest is 8.5. Right now, we're adding at the 4.5 level. So 4.5 is doing nothing to change. 2.6 and 1.9 are reducing significant the amount that we add to the existing stored carbon dioxide in the atmosphere. And 7 and 8.5 are our worst case scenarios, where we continue to grow the amount of carbon that we put in the atmosphere on an annual basis. So if you look at the top map that's in there, it says if we do worst case and continue dump massive amounts of carbon dioxide in the atmosphere, even stronger than we're doing right now, by 2100, the temperature at a global average will be 5 degrees centigrade warmer than it than it was in 1950. If we can reduce it by 1.9 to 1.9, we will get up, touch 2 degrees, and we will be dropping back down a little bit by 2100. Any questions on interpreting that stuff for the temperature? Does that kind of make sense? All right, and the B says, what happens to the Arctic sea ice as a measure of how much we lose from the cryosphere? And what we see is all but the 2 best, least carbon dioxide producing scenarios have, by 2050, the September sea ice is gone. And it will continue to be less and less ice up there in the even in the winter months by 2100, with even continuing to discharge at the same rates we're discharging right now. And we will, in this scenario, never get back to even close to what we had at Arctic sea ice in 1950. That does not recover by 2100. It is not getting any worse by the 2 scenarios, which would be greatly reducing the amount of carbon dioxide, which are represented by the numbers 1.9 and 2.6. And then we've got the, go ahead, please.
So, Dr. King, how does that correlate with the rise of sea levels, particularly in Miami, Florida?
Every bit of that ice will add to sea level, but that's not the most significant part of the story. The biggest component of sea level rise will be from the global warming for the heat that goes into the water. Because when you heat the water up, it expands. So the more and more heat, the more and more you're going to get sea level rise. Sea level rise is shown over here on the chart that's on the far right. By 2300, we could be looking at sea level rise of 3 meters in the best conditions, and up to 7 meters if we continue to dump at the high levels. That's what that's saying. 2100, you're going to see some numbers on the significant sea level rise. And to give you a correlation, if you look back over on the left-hand side of the chart at the bottom, you see that SP3 is carbon that we're doing now. SP70 doubles the carbon that we're dumping by 2100, and 8.5 doubles the amount of carbon we're dumping by 2050. So that gives you a level of, here's what we are going to have to do. We have to significantly reduce the amount of carbon that we're doing below the levels we're doing right now by 2050 to avert some of the most catastrophic effects that we're seeing. And the confidence levels in AR5, the confidence levels for this were like 50%. The confidence levels now are 95%. There's as close to absolute certainty as you can get to when you're doing complete computer modeling and understanding the impacts, because we have now been able to build a model that has all the different components in it, where before we had just the more simpler versions of how the Earth is reacting to more carbon dioxide, more methane. So these show you the best estimates for temperature over the short, midterm, and long term. Now, recognize again, what I'm listing here as temperature is the global total average temperature. Many places in the northern hemisphere are going to be much warmer than this. Where it shows for SP85, best estimate is 4.4 degrees centigrade. Many places in the continental United States in the mid-country are going to be 6, 7, and 8 degrees warmer because of the continental effect that we already understand when we model climate. This is the world average temperature. So here we're back to the chart we skipped to first. Annual precipitation. Well, the warmer it gets, the more evaporation you get. So there's going to be more moisture floating around. But if I go back and look at what I talked about in my ecosystem and talking about the global climate map, the climate classification map, the amount of rainfall and the times that you get it are going to change dramatically under the new scenario of global warming. There are places that are going to be significantly drier. There will be places that will be significantly wetter than they are. Look at this, of the 6 boxes there, look at the one simulated change for 2 degrees centigrade. And it shows, wow, look at the Sahara Desert, Africa, Northern Africa, and it shows that, wow, that's going to be 30% more rainfall than it's had before. That's where you have to look at and go like, oh, what does that really mean? Well, the average rainfall in the Sahara Desert is 1 inch a year. So 30% more for them means that they're going to get 1.3 inches of rain a year. Sometimes it's hard to interpret exactly the cause and effects of what that really says. Places where people live, where there's going to be significantly more rainfall, that is something that's significant, that we really have concern from a human security standpoint. But what it does show us is we define climate as weather over time. Climate is going to change in the amount of rainfall you get, when you get it, and how intense it's going to be. And what we have seen from the extremes of weather that we've seen in the United States, the cost of extreme weather is going up and up, in both in dollars and human lives over the last 25 years. And this says it's not going to get better when you have temperatures going up by 4 degrees centigrade. So I'm about to quit talking and then we can have some discussion. AR6, Assessment Report 6, substantiates and validates and reduces the uncertainty from the findings we have talked about before from the UN IPCC work. Climate change is absolutely human caused in a one-to-one relationship with the total amount of carbon, of heat absorbing greenhouse gases that we dump into the atmosphere, driven by carbon dioxide from energy burning. It's worse than reported before in the danger to be expected from extreme weather. They had, because of the error bounds and the uncertainty in the data previously, they had not spoken strongly about the threats, both from human life and economic loss from extreme weather. And they're much stronger on it in this report because the uncertainty has gone away. And actually, what we thought was bad is worse than we thought. Progress in mitigating the impacts have been negative. We have lost ground. From what we hoped to do from the 2005 standards, we haven't done it. We have not done it. And certainly the United States dropping out for 4 years was a significant part of it. Not only because we didn't reduce what we were hoping to do, which we didn't, but we didn't provide leadership and support to try to help others do well too. One of the big discussions at the COP26 in Glasgow was, how are the developed nations going to help the smaller nations to participate in this process so that we can get reductions from them too? Just saying they need to pay for it and they need to go on and be good boys and do that, good boys and girls and do that, isn't going to work. They can't afford it. They don't have the resources to change from the systems that they have now. And finally, the unavoidable consequences of climate change, we will see as very significant by 2050 and maybe at the world crisis level by 2100. Certainly at 2100, if we follow any of the top 3 scenarios in the amount of carbon we produce over the next 80 years. And that's what the report basically said to me as I dug through it. There are a lot of good details in it. There are a lot of things that'll answer specific questions like Jim brought up. But I think for an overview, that's where I'm going to stop. And hopefully we can have a good discussion and ask some questions. That's probably less positive than I've been in other times, but I think it's time to fish or cut bait, as we would say down south. Questions?
Yeah, how are we all supposed to
I
sleep
will-
tonight?
Say again?
Start.
How are we all supposed to sleep tonight?
I had this wonderful young lady, not one young lady, she was an older lady. I was speaking to the farmers out in Kansas, and she says, that was really very good, but you sure are scary. I didn't mean to scare anybody, but you're not the ones I would like to give sleepless nights to, but I don't know how we get to the right spot. It is what it is. You guys know me from 7 times before, 6 times before. I'm not typically a gloom and doom guy, but that's what the data says. I don't paint it a different color.
Can I put some stuff out there?
Please.
Okay. I agree. When you talk globally, it's hard for me to get my brain around that and to know really what I'm supposed to do. So I have to drill that back down to myself. And I know that, I mean, I've kind of been researching this topic ever since I knew you were going to give this presentation. So what I had found was that the Earth's soil holds up to 25 gigatons of carbon, which is 3 times more than the atmosphere and 4 times more than plants and animals. And so that as gardeners, individually, we need to do what we can to keep this carbon in the soil, which means, and so this like is, I asked about the agriculture, all these that are still doing the tilling, they are releasing carbon into the air. And, you know, pluses and all this, digging up the earth, they're releasing carbon into the air. And so, like I said, drilling that back down to myself as an individual gardener, I just layer on stuff. I don't dig in my garden. And I think encouraging people to protect the soil is something that do on an individual and a community. You know, it just boggles the mind how you get people to change statewide, globally. I don't know. So that's my comment.
I think last week, the Kansas City Star newspaper had several pages of photos and stories about what is happening in the area of regenerative agriculture in the Kansas and Missouri. and they cited some of the opinions from the movie Kiss the Ground. Chris, do you have any thoughts about the capability of using natural methods to cause the soil to reabsorb some of the CO2 that has gotten into the atmosphere, and doing this naturally?
That's absolutely one of my all of the above solutions. And you're seeing more and more discussion about it at the big agricultural level too. They recognize if you can do that at the little level, and oh, by the way, you end up with a richer soil that produces better and is more sustainable, and you don't lose all your soil from turning it over too much and aspirating it in the. There's a lot of good work. Kansas State University is doing a lot of leading edge kind of stuff, and I think most of the big agricultural research centers, it's a topic of much interest and very positive. I think it's a real win-win because they get what they want in a more sustainable way, and long term, it's a profitable way for them to do their business. So that's got to be a significant, because to me that's almost like that's free.
Some of the solutions that Bill Gates has proposed would take 10 years or longer to scale up to where it has any kind of an impact. We can't wait 10 years.
No, we can't wait 10 years, but we can phase ourselves in as fast as we can. Some people can do it better and faster. Other people don't have the resources to immediately jump to it, but they can be supported. That's why, as sad as it is, it's not going to happen immediately. We're not going to get rid of even coal immediately. Unfortunately, we just backed off of stop coal to phase out coal. What does that mean? Is we're going to be putting up with coal for longer than we wanted to because of the economics and the socioeconomics of the process to get rid of it. And to me, coal is one in the world. Go ahead.
Chris, I've got a question for you. This is Chad. So, you know, a lot of what we hear about encouraging folks to be greener, if you will, is to, you know, buy an electric car, get solar panels, those sorts of things. But I've heard kind of criticism even from the environmental community about some of those types of efforts, saying, you know, the lithium mining in Bolivia for solar panels is, you know, destroying the environment down there. I saw a recent article talking about the lifelong carbon footprint of an electric car versus gasoline powered car is higher just because of all of the energy that it takes to make the batteries. Do you have any thoughts or comments or knowledge about that issue, about, you know, some of these green things being attacked? It may be, you know, I've wondered, is it just the petroleum industry doing that, or is there real issues about some of the green technologies that we kind of prop up as, you know, our saviors?
Well, the first thing I learned about the environmental business was there's no such thing as a free lunch. There's no absolute 100% good thing. It costs to build a wind system. It costs to build any of the systems that we're talking about where we're doing it with technology. That's why I just was so favorable about the soil thing. A lot of that is done without building, without having to spend some of your carbon resources to create what you want to use for energy. I think solar systems have improved magnificently in the last 10 or 15 years. They last much, much longer. Their energy footprint is much, much smaller. So that, I think the whole energy, renewable energy system is evolving to being both a cost-effective solution and an energy-effective solution. Now, I've seen the same thing. Wind is all a subterfuge. It costs more to build one than it actually produces, and things like that. If it costs more to build it than it produced, they wouldn't do it. They wouldn't be voluntarily building those things right now. But it does cost, and they have a footprint too. I think it's getting a lot better than it was. I know it's a lot better than it was 10 or 15 years ago. Those systems are much, much better, last better, are less expensive from an energy standpoint and an economic standpoint to build. So your return on investment is better, and that's why they're selling them.
All right, thanks, Chris. Hey, I'm going to call on Rick. You got your hand up.
Okay. Thanks, and thanks for your talk, Chris. One observation and then one question. One of the problems with India and the energy production is that is so tied in with to decrease in poverty. So it really requires energy to decrease poverty until we can get carbon-free systems that are going to be economic for India and other places to be able to lift people out of poverty without producing CO2 or some equivalent. It's going to be hard. Yeah. There's just so much of a driver internally inside their countries to do that. But one question, after the Paris Accord, all the countries committed to nationally defined contributions to reducing CO2. Do you see any utility in trying to hold countries, feet to the fire, so to speak, with what they have as their declared national defined contributions?
No, I don't. I think that that proved to be a failure. And of course, we highlighted that by walking away from the thing. I think we recognize we got to find a better system. We got to build a better system. Somebody asked a question early on about the carbon taxing approach to doing some of that. Some of that will be able to bring that. You got to have a forcing function to get people to do something they really not quite want to do. And so what is your forcing function for a voluntary system that has no enforcement process for it? So I just don't think that, as it seemed like a good idea at the time, it proved that it wasn't going to work. It proved that it wasn't going to work when we walked away from it. And then we saw Brazil, they got a new government and that changed. And even Canada, and that system I don't think will work. Personal opinion.
All right, I'm going to call on Annette, who hasn't had a chance to speak yet.
Thank you. I was wondering what your feelings are about the drawdown. I've been reading on that, and I mean, like comparing the scientists that are working on the IPCC and the people in all different fields that are working on the drawdown ideas for change.
Help me out and define what you're talking about in drawdown.
There's a book that came out several years ago called Drawdown, and it lists out the top 80 ways to lower carbon emissions, and it has 20 extra ones that are not yet technologically able yet. I don't know if you know the book, but it's been popular in environmental circles.
Okay, I admit I haven't read that book, so.
Yeah, Paul Hawken was the editor of that compendium, which was a bunch of contributions from a bunch of scientists working in various areas. Paul Hawken.
Again, any little piece that will reduce the overall contribution to carbon, it ought to be considered. There is not one big thing that's going to fix it. It is a lot of little things.
And if,
all right, I'm going to, Annette, are you done?
If I may just follow up with just one thing. So I was, like I say, reading that book and looking for some of the biggest changes that, just some of the top 5, and so forth. And there's a lot of talk about changing our diets, of course, to more plant-based.
Yeah.
And I haven't heard mention of that. And it's probably not a super popular thing for a lot of people as far as wanting to do it. Can you speak to that just a little bit, please?
Well, that's going to be a freedom of choice thing. Yes, what they're talking about, that particularly for the beef industry, is a very significant thing. You may have noticed that the beef industry has already gone out in the social media and on the public media, trying to deal with that. They're talking about they're developing ways to greatly reduce the amount of carbon that are products of their process, of the growing of beef and the production of beef, ways that they can capture their own carbon dioxide. Actually, methane is one of the big ones they're worried about in the beef industry. So you're seeing a counter to those things, saying that you don't have to change your diet. We can do what you want to do by changing the way we run the production process. Again, I go back, if we could do some of both, then maybe we can achieve a significant reduction in the amount of methane and carbon that comes out of the agricultural beef and chicken and the meat production processes. God, we couldn't get Americans to take a shot to keep from killing themselves. So I don't know how you're going to get them to change their diet and some of these other things. I've been pretty disappointed in the national response to a national disaster that we ask people to step up and help with. So that's a personal problem of mine, obviously.
All right.
I'd like to hear from
you.
Bob Birkebeil, who's been waiting patiently and hasn't had a chance to speak yet. Bob?
Hey, Bob.
Thanks. I just wanted to, first of all, thanks for a really clear presentation on a very complicated subject. I appreciate that. But I want to put a little more emphasis on all the work that Paul Hawken, who's the author or the overseeing manager of Drawdown, but also his newer book, Regeneration, Reversing Climate Change in One Generation. And he and the team that went into creating that, I think, have taken it to the next level. I think he would tell you he's much more excited about it than he was Drawdown. So I would encourage you to check that out.
I'm going to read that one.
One of the things both of them emphasize is regen agriculture and managing soil and landscape in a different way. And that is one of the things you appropriately talked about. All these things cost something, but actually one of the things that not only doesn't cost, it costs less, and farmers make more money with fewer inputs and a lot less equipment using these new strategies. And we are, after all, in the heartland, in the breadbasket of America. And so adopting these strategies, I believe, costs less, produces higher quality products for our consumption while sequestering carbon and building soil.
I agree.
And it's certainly, we all need to know more about it. We need to encourage all of our neighbors to embrace these new sources of food, to encourage the people who have already made that shift. I think it takes a cultural change to make this happen. And I believe that there's a greater chance for that cultural change to be created in the heartland than any other place on the planet that I know of. And I think we should take heart and do everything we can to add fire to that potential change.
Well, I agree completely. The one thing that we're going to have to notice that there's another variable in this, and that's water.
Yes. Yeah.
Water is changing now. Availability for the farmer community, and particularly in the heartland, is significantly different. Both the natural and their ability to mine and harvest water from other sources. So all of those is going to drive them to change, whether they want to go or not. It's can we get to a change that does what these regeneration and these other books are talking about? I think we can, but it's going to be a tough slog.
No question about it. But one of the things pointed out in regeneration and other sources is that by managing the land differently, particularly with respect to mycelium, will in fact, one of the people working on this actually sent me a note and said, oh my God, it's actually generating water. And of course, it wasn't really generating water, it was just making more use of water, and it was more visible and more, for the first time, revealing its presence. But I think all of those things are worth our attention and our exploration.
Absolutely. Absolutely.
Hey, Chris, would you unshare your screen, and then that would allow more tiles to be viewed? And then I'm going to call on Dan, and then Jim, and then
There you go.
Al. Great. Dan, go ahead.
Yeah, I was, you mentioned that you talked to some Kansas residents, like rural Kansas residents, if I understood that right.
I talked to the Kansas Farmers Union and then one other farmers organization. I actually spoke at their national convention.
Oh, okay. Well, that's a start. Yeah, one of the things, I mean, in Kansas, I mean, as you're probably well aware that the cost of renewable, I mean, of wind power, wind turbines, using a lot, wind farms and now solar farms, is the cost of producing electricity that way is less than coal is at this point. So, I mean, Kansas could play a big role in this, but I think there's just this huge messaging shortfall in rural areas. Is like there are answers out there, right? So, and they have, they have the land, they have but I think they just need to know that this is a good answer to some of the problems that we're facing, but they, not necessarily saying that they have to participate in climate change mitigation, because they're not going to buy off on that, but certainly economic incentives.
Dan, I'll tell you that my engagements with those folks, they know there's a change already because they can't do what they were doing before. They didn't have the water, the temperature domain was different. So they already recognized they were going to have to change. They were receptive to finding answers to the thing. I was very, very impressed in working with them. But you're right, though, the messaging, it has to be shown to them what can be done. But yeah, Kansas is a great place for that to take root. How about that for a no pun intended here.
All right, thanks.
All right, Jim. Are you there, Jim? Your video is muted. All right, we're going to go ahead and go to Al. Maybe Jim's taking a break. Al, you want to go ahead?
Yeah, before I make my comment, I'd like to apologize to everyone if I step on anybody's toes. But politics is a reality. The former president didn't do a damn thing for 4 years. And if he gets elected, which is a possibility in 2024, I want to know if 8 years will make a difference in terms of our survival. Can you answer that, Wendell?
It raises the risk more and more. 4 years made a difference. We lost 4 years of capability to begin the fight. We lost support for many of the renewable energy sources and research to support the things we're talking about. It went in the wrong place. It went into coal and oil and exploration. And so, yes, 4 years more would make a hell of a difference, and it wouldn't be a good difference. We're on the critical path, as we say, when we do engineering design, and anything that leaves that path and slows us down is a risk. I'm sure of it.
Can we survive it?
What's we? Is it 1 billion people? Is it 2 billion people? Is it the United States? Will all of us survive it? No. We'll see, as Rick and I talk about, the incidence of disease will increase mightily because there's going to be more refugees. This allows disease to spread over those regions which are now more conducive to them because it's warmer and wetter, you'll see the disease and the vector-borne diseases and those kind of things more and more across the global population. And then you're going to see mass migrations because a whole lot of people are going to be displaced, driven by extreme weather and sea level rise. So we will not survive it. Some may. I don't fall into that. I can now say one of the catastrophic effects that will end mankind is going to occur, but there are some of those in the climate change scenario. Some exist that will put 100-meter sea level rise in a very, very rapid time, or we'll see a complete change in the global climate because we break down the natural cycles that don't exist anymore. There are scenarios that take mankind off the earth and most of the rest of the planet. Probably the little critters that survived the first 2 million years will still be there, but we're a fragile beast compared to a lot of the things that are out there. I'll shut there. There's lots of questions. Go ahead.
All right, Jim, are you back? You had your hand up earlier. All right. Well, Fred, let's go with
Hey,
Fred.
Fred.
Yeah, thank you. Back to water again, and I'm thinking real,
That's what I love now. You're back
real
home.
big, real strange, big picture stuff here. As massive amounts of water are relocated from mountainous areas and the Arctic areas into, for example, the Pacific Basin, huge, enormous weight burden is elevated on the earth underneath the Pacific Basin. And there's uplift on both sides of the Pacific Ocean. When I was teaching earth science in the early 1970s, and I said something about tsunamis, nobody none of my students had any idea what a tsunami was. Well, guess what? In the last, pick a number, 20 years maybe, we've had Fukushima, we've had the big one in Indonesia, we've had several. Okay, this is like maybe a tertiary effect or something of global warming. But when you relocate that much water on the surface of the planet, you're going to put stresses on these fault lines that basically outline places like the Pacific. Do the military planners, do they think, I think we have a higher probability of that big tsunami in the Pacific Northwest here any year now? Or maybe we have a probability of a repeat of some other major tsunami someplace else, like Indonesia is sitting, Japan, we're already seeing them there. Does that get into your conversation, your military planning, your strategic planning, your secondary, tertiary impact stuff?
I know there's been some planning and they look at it specifically on the Pacific coast because they're exposed to the ring of fire, which is you know what that is, the massive fault lines that ring around the Pacific Ocean, and the ability of those to get to Hawaii is very simple and to even impact the West Coast. So I know there's some of that, and those people who do emergency planning in those states and work with the military, those things are mostly National Guard activities within the military. That just is the way we're organized, and they work with the state governments there. So some of it is, but it's not the biggest priority we're looking at. The big scary one for us is probably the Gulf Coast still, and the ability of massive hurricanes and the levels and the frequency of those and how it's picking up there, and the number of people exposed because we built in the wrong places and we allowed overdevelopment in areas that we know are candidates for impacts from those things. So the tsunami is not the highest priority in most places, but a few places. And Alaska, of course, it is up there because they've seen they're as part of the final part of that Pacific ring of fire, aren't they? That fault line goes up there and then rings all the way back around. Yeah. So you're more expert than that. You have to pass judgment on that. But no, it's probably not the biggest, scariest thing that we spend time thinking about in the military.
All right, well, I'm watching our time. We're about 9 minutes till 9. Jim, are you still there? You had your hand up earlier. Or does anyone else have a question that they'd like to raise here in the final moments? I have a closing.
Yeah, I thought I might throw out there used to be talk about shifting the Gulf Stream to where it would actually
Reverse.
instead of warming Europe, it would actually pitch Europe into a deep winter, like it was several centuries ago.
Yeah, they made a movie about that.
What?
They made a movie about that, except they did it in New York.
Yeah, yeah. Is that still a likelihood? They cited that as an example of a tipping point.
It's one of those catastrophic events that are so cataclysmic that it could be earth-ending, and it's still one of those things that's out there and is feasible, but the probability, it can't be calculated. You know, it's in there with global nuclear war. Feasible, but what's the probability of it? We haven't figured it out yet. It may be big, it may be little, but it's scary.
All right, any final questions or comments? And through here. All right. Well,
it's good to see Chris back again in good health.
Yeah.
Yes,
Hello.
Chris. Thanks so much for presenting for us again, Chris.
Well, I learned as much as I gave. I've found some
Wow.
places I gotta go do a little bit more reading on the regeneration, but that sounds like a good thing to get into.
Sure. Well, we appreciate all you do. Do you have any final thoughts for us before I do a little closing?
No, just don't quit. We got to get in there and start digging up. We got to find some people that will be responsible and recognize change is going to come. If we don't manage it, it's going to be change we don't like. So we have got to work as a community. The comment about doing it from the ground up because it's just too overwhelming when you get at the top, I think that was a really, really good comment. You guys in Kansas City have been working it from the bottom up, and the progress is quite amazing. And I came here to Tennessee and they haven't, and there's nothing. It is dead in the water here because we don't have people like you guys that have been willing to go out and do a little bit every day that you could and to be responsible and concerned. So thank you all.
All right. Well, thanks so much, Chris. Everybody, thanks for coming out tonight. We'll have another program. Most likely, it may be the second Monday in January. Let me look at the calendar here. It kind of depends on how it falls. Yeah, it'll be the second Monday in January. So please look out for your email. If you haven't signed up for our emails yet, you can email me at chadc@sskc.org or put us a message on the board here before we go. Yeah, I think this has been a great presentation. It's been heavy, but important to hear. And so as the pastor type, I want to share kind of how do we deal with something so heavy. We want to let it move us to action, but we also need to take care of our well-being. So I have a quote here, a meditation, if you will, from another Wendell, from Wendell Berry. And this is from The Peace of Wild Things. And so this is something that we can do as we're working hard to care for creation, as we're doing our part and encouraging others to do the same. This is something that we can do to renew our spirit. So it says, when despair for the world grows in me, and I wake in the night at the least sound, in fear of what my life and my children's lives may be, I go and lie down where the wood drake rests his beauty on the water, and the great heron feeds. I come into the peace of wild things, do not tax their lives with forethought of grief. I come into the presence of still water, and I feel above me the day-blind stars waiting with their light. For a time I rest in the grace of the world, and I am free. So all of this talk about caring for creation, we don't want to get away from allowing creation to renew our spirits as well. In the coming years, I'll do a presentation here in 2022 about the connection between nature and our well-being. So be looking out for that. But in the meantime, do your part to get outside, enjoy creation, take a walk in nature, pet your dog, your cat, your animal friend, feed the birds, do what you can to renew your spirit as we do our part to care for creation. Without further ado, thanks for coming, and we'll see you next month.